One.
Hi.
Here.
Welcome to Breakfast in Biology. This is day 29 of the Great Experiment. And we're happy to see you. That's all I have. Attendance form in the chat. Who's here today?
Let's see. Who is here today? Eli was here. Darius, Elijah, Alexia is back. Zuli, Cameron,
Abby.
Cohen, Cody, Abby, Emily, Zuli,
Lurker.
Emma. No, you may not.
William Hatfield.
Sam.
The McCoys.
The McCoys. The real McCoys?
The Hatfields and the McCoys are both here.
Oh. Connor, Lexi,
Jocelyn.
Erica, Mark.
Diana. Ola. Yeah. All right. So Emily, looks like I think we got Gladys. I think we got most people. If we didn't say your name, Xavier, did we say Xavier? We certainly apologize because we like to say your names.
That's why I didn't say Xavier, said Mark. But Gladys and Emily and Preston are here too.
Friday, we started talking about the cell reproduction, right? And so we're going to talk about that more today. Let me share my screen with you. And that worked good. I guess it would help if I turn the presentation mode on. All right. So on Monday, we were talking about stuff, right? What process did we learn about? I'm sorry, guys. Give me a second here. This is all. We're talking about cell reproduction, right? All right. So we went through and we talked about replication and how it was messy and how we wrap those things up and we make chromosomes. We talked about how there's like two sister chromatids. We talked about how this is two chromosomes here, but 4 pieces of DNA. And then Mrs. Smith argued with me, but then she caved afterwards and said that I was right. And so I would just like everybody to get out a note, a piece of paper, and a pencil right now and just write down that on Friday, Mr. Suter was right for once, because it never happens because she's smarter than I am. So today we want to talk about specifically mitosis. And I want you to look at this next picture. There's more new names down there. I like to see that. I want you to look at this next picture and tell me what's happening. So watch this. What's happening here? Somebody tell me in the chat. Finley just popped in. Maya, I hope you had a good birthday on Saturday. What's happening here? Do you recognize things? Look at this. It just started over. You recognizing anything? Salika said mitosis. Yeah, so what is that? Cell division from Radhika. Yeah, good. And there's things that you should recognize. You should recognize DNA. You should recognize the chromosomes we talked about. On Friday, we asked, well, you know, if chromosomes can't leave the nucleus, how do we share them between two new cells? And Eli said that the bag disappears. Mrs. Smith had her yarn in a bag, and he said the bag disappears. And if you're looking at that, you see right about now the bag disappearing, right? The nuclear membrane goes away. So you should notice these things. You could probably notice centrioles, which we talked about. We talked about cell parts, the nuclear membrane. There's things going on here that you notice. And so where I want to start with you today is right here on this diagram. And before we talk about anything to do with mitosis or cell division, let's talk about this diagram. Take a close look at this diagram, because I think a lot of students get confused when they see this diagram and they don't ever take the time to look at it and see what's happening. So if you just kind of zero in on that and look at it, I see I have A here, B, C, D, E, F, G, H, J, I pointing to this whole thing. This is kind of cut out into one section. Arrows pointing this way, telling me I'm going this way. The A arrow is going this way, telling me I'm going this way. So there's a cycle, something happening in a circle. And what you see if you stop and you think about it, is that A is one thing that takes up most of this diagram. But then A can be divided into part B, C, and D. So A goes from here to here, but it can be divided into B, C, and D. And then after A, we have this like pi wedge here, which that's the other section. And that can be divided into E, F, G, or H. And all of those have a name called I. And then there's this little section after H called J before we start over. And so if you think about that and think about what we're about to tell you, that will make total sense, I think. So today what we want to focus on is the cell cycle as a whole, and then a very brief preview of what mitosis is. And then we have something we want you to do. And we plan on being out of here pretty quickly because we want you to have time to work on that thing. So, cell cycle, same diagram, but now it has labels. Look what happens. A, from the last diagram, is interphase. Interphase takes up most of the cell. So what is interphase? That's when the cell does what the cell does. Look, we can break that up into the G1, the S, and the G2 phase. G1 says growth. Well, let's not even get into that. And then we can break up our little pi wedge into cell division, or mitosis. But notice something. Not all of cell division is mitosis. Do you see that on the diagram? So mitosis is prophase, metaphase, anaphase, telophase. And then there's this little cytokinesis thing here. Mrs. Smith is going to talk about this briefly here in a second. Let's look at another picture. Same picture. We start here. Interphase starts here, goes the whole way around. Here we have cell division. And we have mitosis and cytokinesis in cell division. During G1, cellular contents, excluding the chromosomes, are duplicated. Which is a really weird way to write that. I didn't see that before I put that picture in. But this is where we copy the DNA. This is where replication happens.
No.
I'm sorry. Thank you. This is cell growth. That's what I want you to know. Cell growth. Cell growth. Over here in the S phase, each of the 46 chromosomes duplicated. That's where replication happens. All right. They got me. That's a weird way to write it. Cell growth, replication, some more cell growth. So here it says the cell double checks the duplicated chromosomes for error, making any needed repairs. So basically, this whole time is when the cell this is what I want you to think about. From here to here, this is when the cell does what it does. It's when it grows. It's when it is a nerve cell. It's when it is a muscle cell. It's when the cell's doing what it's supposed to be doing. Sometime during S, we copy the chromosomes, we replicate the chromosomes, we get ready to divide. That's it. That's the cell cycle. Most of its life, growing, replicating, doing what it's supposed to do. And then we jump into this area of mitosis, and Mrs. Smith is going to talk about that.
So, I always like to think about a cell cycle as like a clock. So if you think about the clock, it's 1 o'clock, it's 1:15, it's 1:30, and then it hits 1:45, and then we start saying 1:45. And so you're in 1 o'clock where we refer to 1 o'clock for most of it. And then for that last little section, we start saying, oh, it's 10 of 2. It's 5 of 2. That's the part where it's the mitosis portion where it's almost ready to be 2 cells. So as we're going through that time cycle, everything has to duplicate because we're separating both the genetic information as well as all of the cytoplasm and everything else that's in the cell. So when we're talking about that individual 1/4 section, we're talking about cell division. And like Mr. Suter said, on that other part, there was one that said cell division, and then there was a part that says mitosis. And so cell division has a little bit more than mitosis. And so what do we mean by that? So if you flip back over to that slide and we look at that, this is showing a picture of mitosis. And so mitosis really is just 2, 3, 4, 5, and then kind of into 6. So if you go to the next one, Mr. Suter, you know, if you look at this, we talk about the phrase IPMAT or PMAT, which always makes me laugh. And usually in class, I show a little picture of a puppy peeing on a pee-pee pad because you can think like, I pee on a mat. I'm a little puppy dog. Okay, so we start at interphase. That's the part that we're talking about, which is why it's in blue, because that's the normal growth portion, cells doing what's supposed to do. Then it goes into the 4 steps specifically of mitosis, prophase, metaphase, anaphase, and telophase or telophase. And then at the conclusion of that, it has to actually separate into 2 cells. So there's a distinction between separating the genetic information, which is what happens in mitosis, and the overall cell division when we're talking about all the rest of the cytoplasmic portion. So mitosis is the genetic separation. And then if you go to the next one, Mr. Suter, we add in cytokinesis. Cytokinesis is the cytoplasmic separation. So if we never had cytokinesis, you could go through mitosis and have duplicated amount of DNA that's actually separated into 2 nuclei, but it never actually separates into 2 cells. So that cytoplasmic separation is the cytokinesis, or cyto meaning cell, kinesis, if you think about like kinesthetics and movement, kind of the movement into 2 separate cells.
Are you loving your iPad?
So slow, just quick overview of PMAT and IPMAT and those stages of mitosis.
Right. So you can guess what we're going to do tomorrow. Tomorrow we're going to go and break down each one of those stages and talk about it a little bit more. So how do we get from interphase, after interphase, into mitosis, and then in cytokinesis? What happens? How do we separate that genetic material? But we started today showing it to you. Watch again.
So by the end of all of this, you should be able to tell us what's happening in each part. Like, okay, when is it officially in prophase? When is it going from prophase and moving, and now it's in metaphase, and now it's in anaphase, and then it's going to telophase, and here is cytokinesis. So, you know, we're going to go into detail about what's happening in each of those things tomorrow.
What's really interesting, and one of the reasons we both wanted you to see this GIF, this animated GIF of this, is because it doesn't stop, right? It doesn't like go to one phase and then stop, and then go to another phase and stop. It just keeps going. And Mrs. Smith, one of her pictures, even said, here's late prophase. And we could actually do early prophase, late prophase, early metaphase, well, late metaphase, early anaphase, to some degree on each one of those. So really important that you just get in your head now, this thing moves. And what's interesting is right about, well, give it a minute here. Right about now, we would stop and go back into interphase. It wouldn't just keep looping. In interphase, here's the last question for the day. Which is longer, interphase or cell division? I say cell division because that includes mitosis and cytokinesis. Which is longer?
Interphase or cell division? Think about the clock.
Waiting for some answers down there in the old chat. Which is longer?
I see Annie and Darius, and Haley and Maya. We've got a lot of interphases popping in now.
Yeah, and a couple cell divisions. So how long? All you have to do is ask yourself, what's happening in cell division? The cell is reproducing. How long is a woman pregnant? 9 months. Is that the majority of her life or a very small fraction of it? It's a very small fraction, meaning that we reproduce for a very small time. You might think about reproducing most of your life, but you only actually reproduce for about a very small time. So, all right.
Oh boy.
Yes. With that, I don't think there's anything more to say. Although I do want to show you one other thing. In Moodle is a link to this document, and we just walk through the upper part of this document. There's a couple questions. They're pretty easy. Double click on this diagram, drag a couple things over. Pretty easy. Label the letters here. We just went over this. Really, we're thinking this is going to take you about 5 to 6, 7, 8 minutes to do. Somewhere in there. Unless you have to go back and rewatch some parts or whatever. There's also in Moodle, up here at the top, there's a link to the eukaryotic cell cycle. There is a little video there. It's like a 4-minute video that walks through the whole cycle with animations and stuff again. So if you're still like, I didn't quite get it, you can click on that and watch that and get it from that. And then tomorrow we'll talk about mitosis.
Mitosis. Woo.
Cool.
Cool.
Friday, midterm marking period grades are due.
Are posted.
Yeah, they're due for us. Yeah. Well, they're due Thursday, right? So they're posted on Friday, which means I got to turn them in on Thursday. Ms. Smith has to turn them in on Thursday. So if you still have that 100.0 for the test, I don't know, maybe do it.
Ta-da!
If you did, like, if you have a 0 for the mutation notes and mutations activity, and you're like, wow, I did that. Why do I have a 0? Because you didn't share it with us? I don't know. Maybe share it. If you have a 0 for the quizzes activity, maybe you didn't send us a link, a little picture to show us that you did it, or maybe you haven't done it. So maybe you could, I don't know, do it. Just saying, just throwing it out there.
And please realize, and we've said it before, but Mr. Stewart and I do not sit at the computer waiting for your papers. So like when it's 3:00 on a Friday, I turn my computers off and I don't look at it again so that I have a break too.
Right. Yeah. Send me emails. Tell me things are done. I grade every morning. Sometime before the live stream, I grade everything that I have. Sometimes in the evening, but you can count on I grade every morning. So if you've turned it in anytime after I shut up right now, it might be tomorrow morning before I put it in the grade book. All right.
And as far as a guest, it just takes a long time. That's why we haven't had people pop in. Yeah.
Because we're trying to get out of here a little quicker, so we're keeping the time limit that we told you. All right. You got anything else, Mrs. Smith?
I just want to make sure that they heard haven't heard it for a while.
We're children, you know that. All right. Have a wonderful day. We will see you later. Stay safe. Wash your hands. We love you. All that stuff.
Miss you.
Yes.